Hello everyone, welcome to a new video on system design. Today I'm going to discuss about another use case that is regarding the Instagram Reels. Okay, let's see how we can go ahead and do the capacity planning for Instagram. Before doing the capacity planning, let's go ahead and see what are the uh, day-to-day activities going on Instagram data center. Okay, so if you consider an average day, let's see what's going to happen on an average day in an Instagram. In the morning, someone from India, they start using their phone, they're using the Instagram, they start scrolling their feeds and all. They start, that's a read request which is coming to the Instagram. Okay, the algorithm just ran the recommendation query against the billions of signals. Okay, during lunch break, again, a creator in Canada or US, they upload 30-second length of reels into Instagram. Okay, that single upload to the raw storage, transcoding into three different varieties of resolutions, then content delivery network distribution into each node across 200 plus POPs. POPs means point of pressure. Okay, and find out the right into millions of follower feeds. Next, in the evening prime time, that is 6 to 9 p.m. when the traffic spikes to three times. This is exactly where we plan for the peak RPS. We are not considering as the average RPS, we are considering as a peak RPS during the peak time. And the overnight, the backup plan will start working on the overnight. The backup runs start and cold data gets triggered into the glacier, and the uh, recommendation models retrain on the day's engagement and signals. Okay, and what happens on Instagram every day? If you see an average mathematical expression, around 500 million plus stories are uploaded, created daily on Instagram, and 100 plus million reels are uploaded, and 140 billion reel views happening per day, as per the Meta report, and 2 billion likes are given across posts and reels, and hundreds of millions of direct messages has been passed, and millions of searches happen through explore and hashtag, and ads are served billions of times across the feed. These are the daily activities happening in Instagram. Okay, every one of this moment is every one of this moment is a request going to the Instagram data center. Okay, multiplying a single uses day by 500 million, and that's the infrastructure. Infrastructure multiply single uses day by 500 million, and that is what the infra has to absorb. Okay, every single day without fail, and that's what the capacity plan is all about. This is where we need to plan the system in a proper way. We need to identify what are the bottleneck, and where we need to implement the load balancer, where we need to implement the cache system, where we need to implement the content delivery network and all. Here comes the plan of action for implementing the um, proper system design and capacity planning. Okay, that's what the capacity planning is all about, making sure the system never notice a difference between a quiet Monday and a viral Saturday evening. Okay, let's go ahead and see few terminologies what we are going to use in the system designing Instagram kind of system. Let's go ahead and see. Okay, this is the template I have created, and I'm using for calculating all the system design for Instagram. Okay, and the purpose is a fully work capacity plan for Instagram Reels around 500 million daily average user. Okay, every yellow cells I can show you in the capacity plan. There are a few cells are there that we can edit them. And these are the yellow cells. We can, if we need, we can edit these values according to your requirement. As of now, I am considering 50 to 500 million as the daily users. Okay. Um, Reels at 500 million daily average users, and around 70 metrics we are going to consider for calculating this capacity planning. Okay, color code, we can just exclude that color code. That is, black text is formula and green background is key output, and blue text and yellow background is editable inputs. Then comes to the metrics. There are 70 metrics we are covering to calculate the capacity planning. Daily average users, requests per user per day, total requests per day, read write ratio, read RPS, write RPS, peak RPS means requests per second. Data size per record, daily storage growth, yearly storage growth, bandwidth calculation, cache requirement, database requirement, replication factor, CDN requirement, backup requirement, and future growth. Let's see the glossary. Glossary means what are the parameters we can consider while doing the capacity planning, and what are their definitions and how to calculate them. Let's go ahead and see. In the glossary, I have divided all the metrics into three categories. One is user metrics, second one is performance metrics, and third one is storage factors. And in the user metrics, we are calculating the user, we are identifying the user activity, engagement, behavioral pattern, and machine learning retrieval. And that is divided into 9 other categories. That is daily average users, monthly average users, requests per user per day, total requests per day, and fan out strategy. Then come to the two-tower model, that is ANN index, 80-20 rule, and backup envelope. Next, come to the performance metrics, that is how the system is performing well, what is the latency and all. That comes into the throughput, latency, traffic spikes, and network capacity. The parameters we use for calculating these parameters or metrics we use for calculating this are RPS, peak factor, read rate ratio, and the bandwidth. Another few parameters are how we are calculating the bandwidth and all from Mbps to Gbps, and content delivery network, ABR, and cache. Then come to the storage layer, data sizing, retention, replication, backup, and overflow. This comes under this picture. And the parameters we use for calculating this are record size, transcoded size, daily storage growth, and yearly storage growth. And next come to the database layer. That is database we are using, replication factor, backup, and retention. Let's go in detail each one of them. Okay. The user metrics. User metrics means the daily average users and monthly average users, or the period of time they will come to know how many users are active on a monthly basis. And on a monthly basis, you have the monthly basis average details. Then there is a factor called stickiness ratio. Stickiness ratio means the amount of usage which is sustained in the system, or those who are coming back very frequently. That is called the stickiness ratio. If we multiply the monthly average usage into stickiness ratio, we will get the daily average usage. Okay, this is what the daily average usage and monthly average usage. As of now, we are considering 50 million as the daily average usage. And requests per user per day, there is the average actions per user per day. Okay, reels are around 300 reels, and chat is on 30 to 60 chat, and social feed is around 50 to 200, and search is 5 to 20. These are the parameters we are considering. Total requests per day, all the requests handled by the system in 24 hours. That is all the total requests per day. If we divided that into 86,400, that is the number of seconds per day, we will get the total requests per second. Then fan out strategy, how many writes are propagated to follower feed. That is called the fan out strategy. Then two-tower model, that is machine learning architecture for recommendation retrieval. Okay, user tower plus item tower. It's a dot product or similar dot product similarity we are calculating. That is ANN retrieval. ANN retrieval, it's not artificial neural network. It's a approximate nearest neighbor. That is called the ANN retrieval. That is next one is the ANN index. That is approximate nearest neighbor index for fast vector search. Tools we use is FIAS or Scannon. Then retrieve the top K candidates in less than 10 milliseconds. Next, we use the 80-20 rule. That means that 20% of the data serve the 80% of the requests. That is called this 80-20 rule. This is used to size the cache requirement. Okay. That is viral reels, concentrate traffic, we call it. Far of envelope means it's a quick estimation. It's not the exact one. Goal is to order of magnitude actually plus or minus 10 into the 10 is the acceptable value. Next, next is the performance metrics. So we can calculate the performance based on this parameter. One is the RPS. RPS is divided into two categories. One is the read RPS, write RPS, and total RPS. Okay. Read RPS, request per second, that is request per day divided by 86,400 will get the request per second. Peak RPS we will consider, we have the peak factor, usually it will be 3 times. We consider 3 times the request per second, it will give the peak request per second. Highest RPS during the high traffic. Average RPS into peak factor, it can be 2 times to 5 times. And peak factor, ratio of the peak hour traffic to the daily average. And read rate ratio, how many reads are happening per single write, that is for the read rate ratio. A bandwidth, data moved over the network per second, RPS into payload size, request per second to payload size, then it has to be converted into GBPS by dividing by 10 raised to 6, we will get the bandwidth in GBPS. GBPS is gigabits per second, that means whatever we get into GBPS, that is gigabytes per second, multiplied by 8 and divided by 100, that we will get the gigabits per second. Content delivery network, that is to cache the video at 200 plus edge point of pressure locations and sized by metadata bandwidth and peak factor. ABA, that is adaptive bitrate streaming, client switches resolution based on their bandwidth. Okay, Instagram usually serves around 3 type of resolution. One is 360, 720, and 1080 pixels. Next, come to the cache layer. That is hot data kept in the fast memory to reduce the DB overhead. Typically, 10 to 20% of the recent data will be saved in the cache layer. Storage requirement. The parameters we use for calculating the storage requirement is record size. How much will be the each record? Average byte stored per write. That is what the record size. Transcoded size. Transcoded size means usually it will save each reels into 3 different resolution. That is 360 pixels. It is around 7 MB. Plus 720 pixel, that is 25 MB, and 1080 pixel, that is 60 MB. Okay, per reel, it is considering around 92 MB per reel. Daily storage growth, new bytes added per day across raw plus transcoder is a daily storage growth. Writes per day into raw plus transcoded side, it is called the daily storage growth. It's around 95,977 terabytes a day. It's not a small value, it's a huge value. The yearly storage growth, the daily storage growth multiplied by 365, we will get the yearly storage growth. And database size, persistent storage, including the index overhead and all. That means if I want to store 100 MB of data, I need to consider around 30 to 40% overhead, because along with the database, I need to save the metadata, index, and other factors, write ahead log and all. So we need to consider that 40% overhead. Okay, that is raw data into 1 plus overhead percentage. Overhead percentage for 20 to 40 percentage. A replication factor, copious data across the cluster. Usually it will be 3, 1 primary and 2 replicate. And backup, that is for the disaster recovery. Usually we can have different kind of backup. We can have the hot backup kind of thing. That is whenever there is something happens, the exact copy will be there. Or incremental backup, delta backup, different kind of backups are there. Retention period, how long the records are kept in primary storage, that is called the retention period. Reels usually 5 years rolling primary, and older data will be moved to the glacial layer. These are all the glossary and what are the parameters we use and how we are calculating all of them. Then go ahead and see how we can do the capacity planning for Instagram. Okay. So there are 3 different sessions. First one is the section input and assumptions. Based on these assumptions, we are going to do the calculation of session B. This is the exact calculation. After the calculation, we can go ahead with the yearly estimate for 1 year, 3 year, and 10-year estimation. This is the projection that based on the first year calculation, what we are going to project. This will be the, if you are considering for 2 year or 3 year, this will be the projection. It's a multiplier. Let's see one by one. The assumptions are daily average user. As we said earlier, we are taking 500 million daily average user. Request per user per day, that is around 300 requests per user per day. Read write ratio, that is read per one write, it's around 260 is the read write ratio considering as per the Instagram current read write ratio, that is read number of reads per one write, that is 260. 450 140 billion views versus 450 million total actions. Okay, every read heavy, that is 260 reads per one write. Peak to average traffic factor, we are considering it as 3x time. Average data size per record, it's around 75 million bytes, that's around 75 MB. We can consider convert that value, that is in bytes. If we convert that into MB, it will be divided by 10 raised to 6, we will get around 75 MB. Media attachment size is attachment rate is 1%, that is every average transcoded media, that is 92 million byte. When we converted that into MB, that is 92 MB, we are converting into 3 transcoded version, that is 320, 360, 720, and 1080 pixels. And cache hit, that is considering around 0.95%, that is CDN edge caches 99% plus feed Redis cache is around 95%, that is 0.95 as the blended target. DB overhead, that is 30% of the DB overhead, including the index metadata of write ahead log and all. Copies, we are considering around. For the replication, we are considering 3x times. So 1 is the primary and 2 for the replica for redundancy. And backup retention multiplier 1.5 times, that is daily, weekly, monthly retention versus primary data. Data retention period is 5 years and seconds in a day 86,400. Based on these assumptions, we are going to make the calculations. Okay, the calculations are total requests per day. How we are calculating the total request per day is daily average user multiplied by request per user. Daily average user multiplied by request per user, that is 500 million into 300. Okay, 500 million into 300, we will get around 150 billion requests per day. 150 billion. Okay, that is what the total request per day. From the total request per day, we can calculate write share total, read share total, total writes per day, total reads per day, average read RPS, average write RPS, and our total average total RPS. Based on this, we can calculate peak RPS. Okay, let's see one by one. Write share total. How we are calculating the write share total? 1 plus 1 by 1 plus read rate ratio. That is how we are calculating the write share total. Read share total R divided by R plus R divided by 1 plus read rate ratio. This is how we are calculating the write share. Total writes per day, it's around 574.71 million writes are happening per day. Total reads per day, it will be around 3 to 4 times. Okay, it's around 149 billion writes are happening. It's multiplied by, there's a total request per day into read share. Read share is, how much is the read share? Read share totally 99 or 99.617%. Then come to the average read RPS. Average read RPS we can calculate using total read reads per day divided by 86,400. We will get the average read RPS, average write RPS, and the total write per day divided by 86,400. That is around 66.65K. And average total RPS is the sum of the above two. It's around 1.74 million. From this, we can calculate the peak total RPS. Peak total RPS is the sum of average RPS into peak factor. Okay, that is the total peak RPS. Peak RPS means there is a peak factor when there is a high throughput, high traffic. That time we are considering to increase the load by 3 times. Load means traffic load. Average data. Next, we are going to calculate the data storage, daily data storage. From there, we can calculate the yearly data storage. So average data size per record, we are considering it as around 75 MB. From there, we can see the daily storage raw requirement is rise per day into raw uploaded size. That is around 43.10 petabytes per day. Okay. From there, we can see the daily storage transcoded media. Transcoded media is we are converting that data into 3 different formats. Even though if it is a small one file, we are considering that will be divided into 3 different codec format. That is 360, 720, and 1020 pixels. That is a transcoded data. Okay, that is writes per day into media rate into transcoded sizes. That is 100% media into 92 MB. That is what the daily storage transcoded media. Daily storage growth, that is around raw upload plus transcoded asset, that is 95.98 petabyte. Daily storage growth is around 95.98. That's the same thing, and that is if we converted that petabyte into terabyte divided by 1000, then we will get around the storage daily storage growth in terabyte. It will be 95,977 terabyte a day. We convert GB to TB and TB to petabytes. This is the petabyte, 95.98 petabyte daily. Then yearly storage multiply into 365, we will get the yearly storage requirement. It's around 35.3p exabyte. Very huge number. Okay, here comes the storage calculation server. Next thing is we need to consider how much bandwidth we require to handle this kind of load. Bandwidth calculation, again, that depend upon the write bandwidth, read bandwidth, and total bandwidth, average and total bandwidth in Gbps. Write bandwidth is around 1.11 terabytes per second is the write bandwidth. Whereas read bandwidth is around read RPS into average payload divided by 10⁶. This is how we can calculate the read bandwidth. It's around 288.82 terabytes per second. Total bandwidth is the sum of those the above two values. It's around 289.93 terabytes per second. Total bandwidth in Gbps, it's around 2.32 petabytes. Peak bandwidth is 3 times the average bandwidth. That is around 6.96 petabyte per second is the total bandwidth, peak bandwidth. Based on that, we can calculate the cache requirement. That is core data in GB. There is daily storage growth into cache hit. That is 95%. It's around 91.18 petabyte is the cache requirement per day. Raw DB size or the retention, that is around 175.16 exabyte. How we are calculating that? Yearly terabyte into retention per year. That is 5-year retention period. That is how we are calculating it. It's around 175.16 exabyte. DB size with overhead, that is around 227.71 exabyte. How we are calculating that one? Raw into 1 plus DB overhead. That is how we are calculating the DB size overhead. So finally, we need to calculate the how much total data by size with replication. That is around in exabyte 683.12 exabyte. We are calculating DB size into replication factor, 3 times the replication factor we need to consider. Media bandwidth, that is read RPS into media rate into transcoded media divided by 10⁶. We will get around 159.11 terabytes per second. Next, come to the content delivery network peak bandwidth. It's around 3.82 petabytes is the content delivery network peak bandwidth, and backup storage requirement is the replicated DB size backup multiplier. That is around 1024.67 exabyte. We are adding a replicated database size into backup multiplier. Backup multiplier will be usually for daily, weekly, and monthly backup we are considering. It's around a backup storage requirement in terabyte. These many values in terabyte is that is 1024674569 terabyte. It's a backup storage requirement. This is in terabyte. We'll convert it into exabyte. 1024.67 exabyte. Let's come to the feature growth. If we want to project this 1 year value into the future value 3 year or 5 year or 10 year, just do a multiplier with that number. This is the 1 year value. If you need to consider the daily average user requirement for the 3 year, just do a multiplication by 3, that is, we will get around 15. The corresponding values will be a multiplier of 3. This is how this projection is. And this is all about the Instagram capacity planning. So far, we have seen the system design and the capacity planning of Instagram reel system. Now we will go ahead and see the end-to-end pipeline, how the data flow is happening, how the recommendation is going to happen. And let's see. There are 7 steps out there. Let's go one by one. The first one is let me increase the size a little bit so that it will be so clear. Yeah. The first one is the user upload. Then it will go to the ingestion phase. In the ingestion phase, we are using Kafka. Then to the transcoding. Transcoding means converting the input data into 3 different formats. That is 360 pixels, 720 pixels, and 1020 pixel. Then it will go to the content moderation system. From there, from the metadata, it will go ahead and get the feature extraction. That features are used for the recommendation system. Once it is go through the recommendation system, then it will feed to the content delivery network and POP. POP means point of pressure. Around 200 point of pressure locations are there for Instagram. That is working in the caching. Those are the content delivery system serving the Instagram. Let's go ahead and see one by one. Okay. First, the user upload the data. Uploading means the chunked multipart that is moving to the pre-sent S3 bucket. That is going through the dedupe check using SHA-256 and it is converting into 5 to 10 MB parallel chunks. Then it will go through the SLO. SLO is less than 5 seconds per chunk is the SLO. Key metrics is for 100 million. This is the key metrics. For upload RPS is 1157. How we are getting it? 100 million divided by number of seconds in a day. Then it will hand off to the ingestion. In the ingestion phase, we are using a Kafka producer. Through REST API, Kafka, the reels will be uploaded and the metadata will be saved in the Cassandra. Here the latency is less than 200 milliseconds and key metrics are write RPS is 1157 we have already seen and the Kafka throughput is 87 MB per second. Then we'll hand over to the transcoding through Kafka consumer group. Okay, here the consumer group will come into picture and the format is FFmpeg and this is the GPU we are using to transcode the incoming data. Then the latency is less than 2 minutes per reel, that is 30-second clip will be generated. For all-tier means we have 3-tier system. One is for transcoding into 360, 720 and 1020 pixel. The key metrics are 3 different files will be generated using the transcoding system. That is 360 pixel, that is around 7 MB, 720 pixel, that is around 25 MB, and 1080 pixel, that is 60 MB output. Then it will be hand off to the moderation queue. Moderation queue means it's a content moderation for security check and all other parameters. The computer vision safety model and human review. For the computer vision, we are using PyTorch computer vision, SQSQ, and Amazon recognition, and not safe for work NFSW and violence check and hate check. It will come in. Latency is it is an automated process. Less than 30 seconds will take per reel. If it is human review secret, then the latency is 4 hours. Key metrics is 95% of them will be gone to the automated system. Only less than 5% will be the human review required. Handover is this once it is content moderation is done, then it will be handover to the feature extraction. Feature extraction, we are extracting the feature for doing the recommendation system and other machine learning parameters. And for the machine learning embedding pipeline, the tech stack is ResNet VAT or Wave2Work 2.0. And but tokenizer, we are using Fire, so Scan and VectorDB. And for the online, we are using Redis, and offline tech stack, we are using Hive. Hive is the data warehouse system. If you know the big data, you know what is Hive. Latency SLO is SLO means service level objective, less than 60 seconds per reel, and feature rate is 50 milliseconds. And key metrics are embedded dimension is 256 to 512 is embedded dimension, and in index update is in 1 second. Then it will be handoff to the next stage, that is stage number 6 is the recommendation system. This is two-tower retrieval and ranking model we are using. Tech stack is two-tower DNN. There is a deep neural network. Then the vector DB uses Fire, so Scan and light BGM ranker we are using, and Redis feed cache. Latency is 50% of the requests will be served in 80 milliseconds. 99% of the requests will be served less than 300 milliseconds. That is SLO. Key metrics is average RPS is this is the average request per second. Peak RPS is 3 times the average request, and top 500 to top 20 it will be converted. Handoff is this is the last stage. We'll be handovering the data to the CDN feed API and CDN point of pressure. That is tech stack we are using GraphQL, graph query language for feed API. It will be feed to 200 plus content delivery network point of pressures. Next, go to the latency. Let's see what is the latency. Feed API, that is less than 50 millisecond for 99% of the requests. Key metrics: content delivery network peak bandwidth is 124 terabits per second. Cache it is 99%. Origin pool, that is cache miss, is less than 1%. And this is all about the Instagram Reels data pipeline, how it is going. This is overall for user upload, ingestion, transcoding, moderation, feature extraction, recommendation system, and feed to the content delivery network to the end users. This is all about the 7-layer architecture for this Instagram Reel system. So I hope you understand the architecture diagrams and the system design and the capacity plan. Thanks for watching this video. Thank you. Have a good day.